Welcome guys, Mr. Bennett here. We're just going to go through what you will need to know about projectiles, right, in terms of this whole topic. So obviously the key function is we're looking at projectiles with the notion of looking at sport. Right, so just some examples of where you might see projectile motion being used, and you know there's a whole range of sports, and intuitively we know that we allow for things when we're playing sport. So we know that the ball will fall. We know that objects move in a parabolic path. So it might be that you're having a device that you're throwing or an object that you're throwing, or it might be you that is actually the projectile itself. So when we start looking at any questions, the things that we need to consider are the following. So what are the effects of air resistance? So in year 11 we didn't really look at that. In year 12 we need to be discussing those and how they work. So what is the best launch angle? Alright, so that might be something we would consider. Alright, so how does a launch angle affect the time of flight and the range? So there are three things that you need to be able to answer when we're starting to look at projectile questions. And keep in mind, they have to be in the concept of the application of real life things. One of the things that we do neglect is spin. So the different types of motion that you'll need to consider is ground to ground, above ground to ground, horizontally to ground, ground to above ground, and above ground to above ground. Now it doesn't really matter, you're looking at 5 different examples there. Really there's only one particular process that you'll use. The difference that you have here is that we talk about our positive vertical displacement or a negative vertical displacement. So all of those different examples use the same formula, the same process. So the formulas that we're going to use, obviously you've seen these last year, is in terms of the vertical displacement equal to the initial vertical velocity times time plus a half of gravity times the time squared. Now keeping in mind we know that in projectile motion, once the projectile's left, the only thing that's really acting on it is gravity. So there's no horizontal acceleration. So therefore that's where we get our range formula here. SH equals VH times T. And we generally use this one over here, the variation of the acceleration formula, to work out the final velocity. So those are generally the formulas that we do use. The steps that you'll need to go through is we certainly need to find the initial vertical and horizontal velocity. So we break that into a right angle triangle, and we use V sine theta and V cosine theta, and that's pretty straightforward. So easy marks in a test or whatever. And then the second thing we'd need to do is find the time of flight. So we substitute into the SV formula. We make sure that if we're going above ground, going upwards, then our SV will be positive. If we're going below our starting position, our SV will be negative. We then rearrange that formula to actually make a quadratic, and then we can either graph it or put it in our graphics calculator and factorise it to find the time. Now to work out the range, we place that into the SH formula. So once we know our horizontal velocity and the time of flight, we can work out how far it goes. So that's pretty straightforward. The sort of another thing that you might need to do is work out the velocity at any time. So we need to calculate the final vertical velocity. We know the horizontal velocity doesn't change, so we use this formula over here to work out our final vertical velocity, and to work out obviously the velocity at that thing we have to use Pythagoras, and to work out our angle that it's travelling at below the horizontal we need to use trigonometry to work that out. Right, and then the following thing would be to find the maximum height of a projectile. So you need to state that obviously at the top the vertical velocity, the final vertical velocity is 0. So we're going to use that formula to work out obviously how long it takes to get to the top of the thing. And once we know our t by rearranging this formula here, because we know that it's minus 9.8, we know that will be whatever our initial vertical velocity is, and that will be 0. Once we've got our time, we can put that into our SV formula, and that will tell us how high our projectile is at any particular time. Now, the other important thing there is to remember that is the height above wherever it starts. Okay, so if you're already 1.5 meters above the ground, then you'd have to work out, you'd have to add the 1.5 meters onto your answer to work out the height above the ground. Alright, so generally any question that we have to do, you would have to go through those 5 steps. Now, obviously, the way they mix it up is to ask you maybe only steps 2 and 5, or 3, 4, 5, or 1, 2. So the idea is to mix up the questions. They will ask you to do any one or parts of those 5 steps. Alright, so but if you could do those 5 steps, then you'll be able to do any question to do with projectile motion. Alright, so again, this is really a repeat of what we did last year to a certain extent. I'm sure that you guys are going to nail this topic. Good luck with it.